more like a pancake, as is the case with very high gain antennas. The dipole radiates equally in all directions around its axis, but does not radiate along the length of the wire itself, hence the donut pattern. Now when we look at dipole coverage, high-gain omnidirectional antennas offer more horizontal coverage area, but the vertical coverage area is much reduced. This characteristic can be an important consideration when you're actually mounting a high-gain omnidirectional antenna onto the ceiling. If the ceiling is too high, the coverage area might not actually reach the floor where the users are located. If a dipole antenna is placed in the center of a single floor of a multi-story building, you have to think that most of its energy will be radiated along that floor, with some significant fraction being sent to the floors above and below the access point. Omnidirectional antennas are typically used when coverage in all directions around the horizontal axis of the antenna is required. Omnidirectional antennas are most effective where large coverage areas are needed around a central point. A good example of this would be placing an omnidirectional antenna in the middle of a large open room. This would provide excellent coverage. When used indoors, the antenna should be placed in the middle of the building or desired coverage area near the ceiling for optimum coverage. Omnidirectional antennas emit a large coverage area in a circular pattern and are suitable for warehouses or trade shows as well, where coverage is usually from one corner of the building to another. Now this is going to differ considerably from semi-directional antennas. Semi-directional antennas come in many different styles and shapes, but some semi-directional antennas frequently are used with wireless LANs. These are known as patch, panel, or Yagi antennas. All of these antennas are generally flat and are designed for wall mounting. Each type has a different coverage characteristic and needs to be examined independently. Now these antennas, which are semi-directional, will direct the energy from the transmitter significantly more in one particular direction rather than in a uniform circular pattern that is common with the omnidirectional antenna. Semi-directional antennas often radiate in a hemispherical or cylindrical coverage pattern. Semi-directional antennas are normally best suited for short and medium range bridging. For example, if you had two office buildings that are across the street from one another and would need to share a network connection, this would be a good scenario in which to implement semi-directional antennas. In a large indoor space, if the transmitter must be located in the corner or at the end of a building, end of a corridor, or in a very large room, a semi-directional antenna would be a good choice to provide the proper coverage. Yagi antennas are most used on short to medium length building-to-building bridges, up to 2 miles. Patch and panel antennas are more typically used on short-range building-to-building and in-building directional links, such as in very long hallways. Many times, during an indoor site survey, engineers will constantly be thinking about how to best locate omnidirectional antennas only. And in some cases, semi-directional antennas provide such long-range coverage that they may eliminate the need for having multiple access points in a building. A really good example of this would be if you had a long hallway with rooms on either side, where several access points with omni antennas would have to be used. But in this case, you may be able to get away with only 1 or 2 access points with properly placed semi-directional antennas, which can save the customer a significant amount of money if done correctly. In some cases, semi-directional antennas have back and side lobes as well, that if used effectively may further reduce the need for additional access points. Specifically, Yagi antennas are appropriate for signal coverage down pathways or aisles in warehouses, as well as rail yards, retail stores, or even manufacturing facilities that do require this type of coverage. The other major type of antenna that you have is what's known as a highly directional antenna. In the case of highly directional, as the name would suggest, highly directional antennas emit the most narrow signal beam possible of any antenna type, and always are going to have the greatest gain of the 3 groups of antennas. Highly directional antennas are typically concave dish-shaped devices. And these antennas are excellent for very long-distance, point-to-point wireless links. Some models are actually referred to as parabolic dishes because of their resemblance to small satellite dishes. Others, which are called grid antennas, due to their perforated design for resistance to wind loading as well. High-gain antennas, though, do not have the coverage area that client devices can use. These antennas are really designed for bridging or for connecting point-to-point communication links and can transmit at distances up to 25 miles. Potential uses of highly directional antennas might be to connect 2 buildings that are miles away from each other and have no line of sight obstructions between them. Additionally, these antennas can be aimed directly at each other within a building in order to blast through an obstruction. This setup would be used in order to get network connectivity to places that cannot be wired and where normal wireless networks will not work. Highly directional antennas have a very narrow beam width and must be accurately aimed at each other for them to be functional. And as you can see, only having one antenna choice is not really what we're focused on. Most of our access points are going to ship with omnidirectional antennas, those dipole antennas, and that's not the end of our discussion. Obviously, you're going to have to understand that different types of antennas can be used for different reasons. Don't be limiting yourself just because that's the only thing that comes with your access point. A good idea when you're dealing with your access points and focused on antennas, you always want to specify that your access points do have removable antenna connections that are industry standard. What that's going to allow is for you to use external antennas that may be of a different variety. Instead of the dipole antenna that ships with the access point, you may be able to use a Yagi antenna or even a patch antenna for being able to broadcast down a long hallway.